Hello, today I have Orchid by Abdul the Killer. Usually I don't get to do his puzzles on here because I have tested them, but this one slipped through my testing procedures and got posted the other day, so I'm going to take a look at it and give it a try. Hope you will too. So let's go through the rules. We have standard Sudoku rules applying, which means we have the digits 1 to 9 once each in every row, every column, and every 3x3 marked box. Now, with the exception of one, all of his puzzles have this shading rule, which says once we have a shaded grid, so for right now it's not shaded at all, but once we have a shaded grid, we'll have something like this, and we'll maybe do it the other way. So we'll have some shaded grid, and every shaded cell will have to be adjacent within its box to the number 1 less than it. And if it's unshaded, it can't be adjacent to the number 1 less than it in its box. So suppose then I had 5, 4, 3, 2, 1, 9, 8. Let's do this actually, 4, something like this. Well, 1 is always going to be unshaded in this, I'm going to call green unshaded in this puzzle. 1 is always going to be unshaded because there is no 0 in the puzzle, so it can't be next to the digit 1 less than it. 9 in this case is also unshaded. 3 is also unshaded because it's not next to the 2, right? 6 will be unshaded. Am I going to did I do this badly? I mean, this is going to be shaded because the centers of these cells are always going to be shaded unless it's a 1. 7 is next to the 6. 8 is next to the 7, so that's also going to be shaded. 5 is next to the 4, so that's going to be shaded. These two are not next to their neighbors, so they would be unshaded, right? So something like that is how the shading rule works. We have yin yang, so when the shading is done, the shading and unshading is going to follow a yin yang pattern. So what a yin yang says is that we have 2 groups of cells essentially, shaded and unshaded, and each group is going to be orthogonally connected to itself, and there will be no 2x2 regions of one type. So you may end up with something like this. Let's see if I can do this well. Probably not. You can do something like this where all of these cells might be, there we go, all of these might be shaded, and all of the cells that I don't have are unshaded, and the unshaded cells form an orthogonally connected set. The shaded cells form an orthogonally connected set, and there are no regions where there's a 2x2 area where it's either all shaded or all unshaded. So there's that. And then we have these arrows, which are the only actual clues in the puzzle, which are, they tell me the number of shaded cells in a particular direction. So let's say this were a 2 here, then that would mean these 2 cells are both shaded. And because there's only 2 cells here. So that's how that would work. That's it. Those are the rules. So I've done a number of these puzzles, so I know a few tricks. But I think the first thing that seems natural to do is go through the cells that are very close to the edge, that point toward the edge, and just fill in what those digits could be. So like, for example, this can only be 1 or 2 because it's only looking at 2 different cells. So it could be that one of them is shaded. It could be that both of them are shaded, but it can't be that none of them are shaded because I can't put a 0 here. And it can't be that 3 of them are shaded because there aren't 3 cells there. So that kind of logic gets me, no more than 3 here, no more than 2 here, no more than 2 here, which is a nice 1-2 pair here. Like this one is because of the left arrow. This one, obviously, because of the down arrow. But this actually gives me a 1. Whoops. Right away because I can only see that, and therefore that has to be shaded. That's probably all. That's all that I see that I need to do here. Now, as I put in this 1, 2, 3, another thing that I've noticed from doing these puzzles is that if I have 2 arrows that are adjacent to each other, that they look in the same direction, I know something about that. And what I know specifically is that this cell is going to be exactly 1 higher than this cell. So how do I know that's true? Well, this cell sees all of the digits that this one sees, right? So row 6C6 sees at most 3 cells. I don't know how many it sees, or I'm sorry, it sees all 3 cells. I don't know how many are shaded, but it's 1, 2, or 3. This one sees all those as well, but it also can't be the same digit as this because they're in the same row. So this sees all of these shaded cells, and but it can't be that these two digits are the same. So what's going to happen is that this cell is going to have to be shaded. So I'm going to use gray for shading and green for unshading. And this will then have to end up being exactly one more because it's going to see all the shaded cells that this one sees, and it sees this cell as well. And actually this can't be one because it's shaded. So we get 2 or 3 here, 3 or 4 here. Same logic's going to apply here. That's either 4 or 5, and that's going to be shaded. But I can actually go one step further. Because this is exactly one step higher than this cell, it is also going to be shaded because that's how the shading rule works. Because this is one cell higher than this sees the digit 1 less than it and is therefore shaded. So we get this nice string of shading when we have these digits that see each other. I didn't notice any others like that. Maybe that it was just that one. Okay, the other trick, now this is going to be a little more complicated that I've learned from doing these puzzles, is that in every column, specifically on the border, this is going to be important, there is a 1, right? There is a 1 on each one, and 1s are always unshaded. So there's definitely something in this row, in this column that's unshaded, and there's definitely something in this column that's unshaded. And because this cell is shaded, and I didn't say this before, but there's a property of yin yang where along a border, you only ever get, in an odd size Sudoku, you'll get exactly. But in general, you can have at most one crossing between shaded and unshaded cells. So for example, you can't have something like this, where you have gray here, green here, green here, and then gray here. You can't do this where you have gray transfers to green and then back to gray. And then back again, right? So if this were all gray, that would be fine, right? So this is fine because I guess you have 2 transitions from gray to green, right? One going from gray to green and one going back. But you can't have more than that, right? So you can't have this be green. And the reason for that is, suppose I tried to have something like this. Then because these are all orthogonally connected, I have to draw a path from the green cells on this side to the green cells on the other side. But however I do that, I'm going to separate the grays down here from the grays up here. So you just can't do it. And now, since I know there's green somewhere in this column, and there's green somewhere in this column, and there's gray here, that means the greens are going to connect this way. So at least all of that is green. And that means this is a green 1 with this being the shaded cell, because these can't both be shaded anymore. And then, can I do more than that? Yeah, so because this has an arrow on it pointing to the right, at least something over here is shaded. Maybe it's right here. That's at least going to give me some shading like that. Oh, and this 1 tells me that these centers in the boxes, are not 1s. And since they're not 1s, they must be shaded, because in the center of a box, it's always adjacent to everything else in the box. So as long as it's not the digit 1, it's going to be adjacent to the digit 1 less than it. Right? The only time that's not going to occur, and actually this cell that I've just highlighted is also true because of this one. So this is green. And now this cell can't be gray, because if this cell were gray, that would go along back to the bottom 3 rows here. So doing that would make a 2 by 2 of gray here. So this must be green, and therefore everything up here must also be green. And that means this is no longer 3 because this looks here. So this is just 2, 3, 4. That's therefore 1, and that's 2. I should probably turn off, sorry, my pencil mark checker. And then these are both shaded because that's a 2. And so this is unshaded to avoid a 2 by 2. This is shaded to avoid a 2 by 2. This has to get out to orthogonally connect to the rest of the shaded cells. So that's shaded. What is this number? It's at least 5. 5, 6. Okay, that's not quite as interesting as I hoped it would be. 'Cause yeah, I don't see a reason these couldn't all be shaded. This can't be shaded because that's going to create a checkerboard pattern. So if this cell is shaded, to avoid a 2 by 2, you're going to have to put unshading here, but that creates a checkerboard pattern. I didn't say this either yet, but it's a fact about yin yang grids that you can't have a checkerboard pattern, because if you do, well, this green cell has to somehow connect to this green cell. So in this case, it'd have to loop around, right? Come around here and kind of connect in like this. But if I do that, I'm preventing this one from getting to this one, right? So if I draw a loop around to this one, that's going to hem in this one from getting around to this one. I can't have both loops because the loops would intersect. So you can't have a checkerboard like that, which means this cell must be unshaded. And same thing's going to be true here, right? Yeah, if this is shaded, to avoid a 2 by 2, that will be unshaded, which will create a checkerboard. So this is unshaded. And now this is not 1. So, okay, I don't know exactly what this digit is, but I think it's 2 or 4. So what could this digit be? Because it sees both directions, and because it's also true that any shaded cells in this row are going to be touching this to avoid this border problem, right? Then what is this cell possible? Well, it's not 1, it's not 3. It's at most 4, right? So I guess just by that it's 2 or 4. But if it's 2, we're going to see shading like this. So at the very least, we get shading like this, right? Because it can't be the case, say, that I have the second shaded cells over here, and then these are green, because then we get the problem of the border crossing, right? So that's got to go adjacent. And so these are the same. They're either both shaded or both unshaded, which for this cell, we already see 4. So this is either 4 or 6. Actually, one of these cells is a 4. I don't know if that's going to be useful, but one of those is definitely a 4. And for the same reason that this is unshaded, because otherwise we get a 2 by 2 here. So this is all unshaded, which makes this shaded by avoiding a 2 by 2. 2 is next to a 1, so one of these is a 1. Can I make this a 1? I think I could. This would just be all unshaded. In fact, I have to, because this is either 1 or 2, and it's not 2. So that's a 1. So that's unshaded. And these, therefore, are shaded because they're not 1s and in the center of their boxes. I think that's... It's only 2-star puzzle, so I'm going to avoid trying to do anything too complicated. This is either 3 or 4, but it's not 4. So it's 3, which means that's unshaded. There's only 1 shaded cell in all of this. I don't know how to use that yet, but that is true, because this already sees 2 of them. This is a 1 here, so that's shaded. 1s are always unshaded. Do I know anything about where 1s can go here? No, I was trying to shade or unshade this too, but I can't do it yet. Only one of these are unshaded. I'm trying to think if that means these are both shaded. I think these are both going to be shaded, but I don't know if I can prove that. No, actually, no, this could be unshaded, and this could get out like that. Okay, never mind. Yeah, that's not correct. Can I use the negative constraint yet? Probably not. This 2 means that's shaded, and that fixes this. It's unshaded, which means this is a 4, which means this is a 2, which means this is also unshaded, and to avoid a checkerboard, that's now shaded. 3 is in one of these. I'll just mark it so I don't forget. 2 is one of these, actually, by Sudoku, which means this is not a 3, because the 3 would be shaded in that case, because it's definitely next to the 2. Yeah, I don't know. I don't know how that 2, 3 resolves yet. 1, 2, 3, 4, 5. This can't be 7 anymore. Nope. I was going to say something about this, but it was complete nonsense. This cell specifically is looking at, it's at least 2, 2 to 5, I'll mark it, but that's not as good as I hoped. This is not 2 shaded cells. I don't see a reason it couldn't be 0. Sorry, this 3 means that's shaded, which means this has to get out, so that's unshaded. And this has to get out, so those are all unshaded. So it's not this, we had a symmetry break here then. In the shading, I mean, obviously there are symmetry breaks in the arrows already. Oh, this is 1, 2, or 3 and not 1 or 3, so that's a 2, which means that's shaded. Which means what? This is unshaded because 1 is going to go up here somewhere, which is not next to the 2, so that's unshaded. This 3, no, it's one of these, so I have one of each. I'm trying to think if unshaded, shaded, unshaded cause any problems. I think that's fine. Okay. So now I will look for, so this is 4 to 7. This is at least 5. So it's not a 1. Let's think about 1s. Where do 1s go? Because it's not next to this. So I have 1s in here. Oh, I get a 1 also though in one of these two. So my 1 is here. 1, this is a 1 because this is either 1 or 2 and it's not 2. So that's a 1, which means this is unshaded. 2, any of these, that doesn't do anything for 2. 2s could go anywhere here. All right, let's finish 1. No, I can't finish. Well, I can put a 1 here at least. Well, is that on one of my 1s? Not here. So I have an X-wing left on 1s, which is what we expect. 2 can't go next to a 1 and be unshaded. So that's a 2. Is that right? Hold on. Where does 2 go in box 1? One of these 4 spots, but not here because of the arrow. And it can't go next to a 1 and be unshaded. So the 2 goes here, which means 3 is going to be in one of these 2 spots because 3 is going to, so another trick about shading puzzles is that if I have a digit in the center and it's not a 9, then the digit above it will be shaded because the digit above it will definitely be adjacent to it. So it will be shaded. So this can't be 3 and these can't be 3. So I get a 3 down here. I get a 3 in one of these spots. And the 2, so this is a 3-2 pair actually. This can't be 3 because of the negative constraint actually. So that's a 3, which doesn't help me with the 2s. This 3 looks up here, which I didn't notice before. So those are all shaded. This has exactly one of these are shaded to make this 2 work, but it can't be shaded unshaded because that makes a checkerboard. So this is shaded. This is unshaded. This has to get out. So that's shaded. This has to get out. So that's unshaded. I don't think I can do anything with that yet. There's nothing about the negative constraint here or here. At least, oh, so right here, the 3 is shaded and the other cell is unshaded to avoid this 2 from doing something. But I just don't think that actually resolves how this goes, unless I'm missing something. So this should be known. It should be a 3. And it's next to the 2. So one of those is a 2. Unfortunately, all of those work with the 1. This is a 1. So these are all unshaded because I already have the shaded cell for this arrow, which means this is a 2 by the arrow, which means those are not 2s, which means that's a 2. 4 then is going to go in one of these, but not here because that violates where the 3 would be. So 4 is going to go up here. This cell is not 3. This cell is not 3. So do I get a 3 in box 8? Hold on. No 3 here. This is not a 3 by the negative constraint. This is not a 3 by the negative constraint. No 3, no 3. I guess I just need this one by the negative constraint. So that's a 3. which means this is a 3 because this is shaded and not next to a 2. And then one of these is a 3, but either of those work, I believe. I don't see a reason why either of those couldn't be a 3. This is not 5. I know this. 1, 2, 3, 4, 5, 6. This is a 6. So 5 is not next to the 6. 5 goes in one of those. I know this one now. That's a 5. So 5 is over here somewhere. All of them work with the 4. Let's just go through my arrows again. This is not a 7 anymore. This is known. That's a 7. I think that's it for positive arrows. This one needs another shaded cell. So this unshading has to get out, which means it's not 3, which means that's my shaded 3. This can no longer be a, oh, this is great. So this can't be a 4 because I already have 5 shaded cells here. It also can't be a 5 because if it's a 5, it's unshaded, so the 4 would have to go in one of those 2 spots, but they're unshaded and would be next to the 3. So that's a 6, which means that's shaded. One of these, no, exactly. One of these is going to be shaded, one of these is going to be unshaded. Actually, I guess I knew from the 1, but it's also true from yin yang. Do I know anything about how that goes? I don't think so. But I could just be missing it. Okay, let's go back to 4s. That's not 4. That's not 4. 4 is one of these 2, which means 4 over here is one of these, all of which work with the 3. Is there any negative constraint I need to worry about with 4s? But no, potentially here, but I mean that's a lot. That's a lot of thought. Somewhere there's a 1. No, one of these is a 1. Yeah, okay, no, that's fine. I'm trying to see. I should know this shading, right? That's shaded because this has to connect to these. So that's shaded. And then, yeah, one of these, I don't know which. I don't know when to turn to this. I feel like I should be able to, but I probably can't yet. Okay, let's think about 4s here. It's not here, it's not here, and it's not here. Which I guess is not that helpful. 4s. It's either 5, 4 or 5, 4. Okay, 5 has to go. Oh, here we go. This 5 means it's not next to a 4, so it's down here. But that is seen, so that's a 4, which means that's a 4, which means that can't be 5 anymore. That's 5. 5's now. I'm not here because that would be next to a 4. It's kind of weak marking. 5 here is here. 5 in box 5 can't go in any of these shaded cells because they're next to the 4. Can't go here because that is next to the 4. So that's my 5. Easier way to see that 5. So one of these is now 5. Not this one because that's next to my 2 4 candidates. So that's 5. So that's not 5. 5 can't be in either of those spots because they are adjacent to all the possible 4s in the box. So 5 is down here, and also not here actually, because that's adjacent to them all as well. So one of these is a 5, which means that's not a 5. That's my 5. Can I do more? I get a 4 or 5 pair up here. Not pair, but two of these 2 cells are 4 or 5. And then whatever cell is here. I probably can do something with this, but I've never been good at thinking through chains like this. If this is 9, we get 9, 8. Because 9 would have to be next to 8. 8 would have to be next to the 7. 7, 6, 5. So that works, actually. If this is 9, we get this is 8, 7, 6, 5. So that doesn't work. So this is not 9, actually. 9, 8, 7. Yeah, that's right. But the 6 will break. I don't know. I probably don't have to do something like that. So what are these? 7, 8, 9. 7 can't go here. 7's in one of those. This can't be 8 now because 8 would force that to be 7. So one of those is 8. Could this be 9? We'd have 9. No, 9, 8. Oh, yeah, that would work. 9, 8, 7. Can this be 9? We'd have 9, 8, 7. So actually, this is an 8 because it can't be 9 and it can't be 7. So then, do I know anything about 9, 7 here? I don't. I could go either way. But this is not 8 anymore. This can't be 6, so that's 7, 8, or 9. Either of those could be 6, though. That's not 6. Yeah, let's just try doing Sudoku on 6s. 6 is in one of those two spots in box 3 because it can't be here because of where the 5 is. So 6 is in one of these two spots, not here because that would be adjacent to wherever the 5 is. So that's 6, that's 5. 5 is one of those. So 4, I don't think that tells me anything about 4s actually. Well, that's not a 4. So this is a 1, 4 pair. So this must be an 8, 9 pair. I think that's all going to be Sudoku. I don't see any. Oh no, this one. 8 can't go next to 7. So that's 9. That's 8. That's not 8. That's not 9. That works. Sorry. I'm just trying to think through. This is not 8 anymore. That's not 6 anymore. That's not 7 anymore. This is between 4, 8, and 9. 4, 5 works, 8, 9 works, 9 works. Okay, I'm trying to go through the centers and seeing. Maybe I should think about centers. 4, 5 works, 5, 6 works. Yeah, okay. How about this one? 3, 4. Yeah, this all just works. Okay. My scanning is failing me. I'm not sure where. Maybe there's a negative constraint I'm missing. 1, 2, 3, 4, 5. So this can't be 5 actually. It's a little bit helpful. But I still get the deadly pattern of wings. Not deadly pattern. I get an unresolved corner mark. This either can't be 5 or can't be 6, which is not a helpful. Oh, it already can't be 6 though. Hold on, can I do more 6s here? One of these, that's not 6 because 6 would definitely be, if this is 6, this is 5, and they'd be adjacent. So the 6 would have to be shaded. So 6 is in one of those cells, which means 6 is in one of these cells, which means 5 can't be here. So 5 is here, which resolves my 5s. Oh no, that resolves my 6s. 6, 4, and then therefore that's not 3. Look at that. This can't be, well, hold on, let's just be more careful. So that's not shaded, that's unshaded. To get out. My yin yang is done. What are these digits? 7, 8, 9. This can't be 9 because 8 will definitely be next to it. This can't be 8 because 7 will definitely next to it. So this is 7, which is not next to 6. 9 will definitely be next to 8. 8 will definitely be next to 7, so this is unresolved. 8, but 8 here resolves it by Sudoku. So that's 7, that's 6, which means this is not 7 anymore, or 6, that's 9, 8, 7, 6. First thing I looked at happened to be correct in that orientation. That's not 6 or 7, so that's 8. 9 will be next to 8, 4 will be next to 3 either way, so that's unresolved. And this is a 7, 9 pair. 7, 8 is not next to 7, which is fine either way. No, hold on. This is 7, 6. I did something bad. This has to be 7, 6, because 9 is one of those. So that's 6, that's 7. That all works. This is a 6, 8, 9 triple. That's a 9 by Sudoku. which can't go next to 8, so that's a 6. 8 has to go next to 7, so that's 7. What do I need here? A 9. 9's not here, so that's a naked 4. 6 is definitely not next to 5, so that's unresolved except by Sudoku. How do I still not know this 2? 3. 3 tells me the 2, tells me the 3, tells me the 2. This is not a 9, it's a 7, 8 pair. 8 will be adjacent to 7, so that's the 8, that's the 7. 4 tells me the 9, 4 pair, and 9 tells me the 6, 9 pair. This is going to be a 1, 8 pair now, which is still unresolved. Here I'll need 4, 7, and 9, so that's a 4. 7 can't be here and adjacent to a 6, so that's the 9, 7. This, I should know where the 6 goes. That's not 6, so this digit I should be known. Is that a 9? 9 has to go next to 8, so therefore it will go next to 7, which is not next to 6. 8 resolves this, 1 resolves this. And I'm not going to know if this is right because I know they never have solution check. But yeah, lovely puzzle. And yeah, it's just, very smooth. It just flowed very naturally. I mean, I've done a lot of these puzzles before, so I kind of know the tricks to look for. Especially that, this happens a lot in these puzzles, but this yin yang border with the ones, I never get tired of finding that and calling that in. So thanks for the puzzle, and thank you for watching, and I'll see you next time.